All right, boys and girls, today we are going to talk about taking fractions and using number lines to multiply fractions. So we're going to start with the fraction 6/3. I want you to draw this in your math notebook so that you have it as a reference so you can look back at it. And we're always going to start in the decompose circle. If you break it down, get your unit fraction first, it'll make all the other steps easier. So we're going to start by decomposing. If we were going to decompose 6/3, our unit fraction is 1/3, so we'd have to have 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. Remember, a unit fraction always has a 1 in the numerator's position. There is always a 1 in the numerator position of a unit fraction. So there we've got it decomposed. 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. Then we're going to move up to the traditional thoughts box, and we want to use multiplication. How can we write this that we decomposed into a multiplication sentence? Well, we know our unit fraction is 1/3. And in order to get 6/3, we're going to have to multiply that by 6. So how we would write that as a traditional thought, it'd be 6 times 1/3. And that would give us 6/3. 6 groups of 1/3. Sometimes it makes it easier, too, if up here you just write 6 groups of 1/3. 6 groups of 1/3. Then we have to think about how can we make an area model that would display 6 groups of 1/3. 6 groups of 1/3. We need to make 6 rectangles, split them into thirds, and remember, each one is going to display 1/3. So you color in one of each. And this is how we would draw an area model for 6 groups of 1/3. I want us to hold off on this linear model. We're going to come back to that. I want us to go down to operations. We already said before that our multiplication fact for 6/3 would be 6 times 1/3. Then we have to think, how could we add to get 1/3? Earlier, or to get 6/3. We could do like we decompose 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. Or we could do something else. We could try 3/3 plus 3/3. That would also give us 6/3. Then we have to think about how could we subtract to get 6/3. We could do 7/3 minus 1/3. I want you to fill in your table so it looks like that linear model should still be blank. We are going to come back to the linear model. We are going to come back to the linear model. All right, so when we talk about linear model, we're talking about a number line. We're talking about a number line. And it's so important that we label our number lines. We've got to make sure we label. We always start at 0. So here we go. We got 0. We got 1/5, 2/5, 3/5, 4/5, and 5/5. And we know that 5/5 is also equal to 1 whole. So I'm just going to put 1 up here. I'm just going to go ahead and put a 1. We know that 5/5 is equal to 1 whole. Now the question I have up here is how would you use a number line to represent 1/5 plus 1/5 plus 1/5? So I've got my unit fraction, and it's 1/5. So I know I'm jumping 1/5 how many times? 1, 2, 3. So I'm going to start at 0, 1, 2, 3. I know that 1/5 plus 1/5 plus 1/5 equals 3/5. I'm going to go ahead and box my answer. This is also could be written as a multiplication fact as 3 times 1/5. 3 times 1/5. And this is how we use a number line to represent multiplication. So, how would you use a number line to represent 7/5? So I said first ask yourself, what is the unit fraction? Remember, I've said this multiple times, a unit fraction always has 1 in the numerator. So we know we got to have 1 in the numerator position. We got to have a 1. And we also know that it's fifths, so our unit fraction is going to be 1/5. 1/5. Okay? And then we have to think, how would we say this in words? We know our unit fraction is 1/5, so we know we're going to have groups of 1/5. And if you look at that numerator, it'll tell you how many groups we're going to have. So we're going to have 7 groups of 1/5. Okay? To write our multiplication sentence, again, we'd write 7 times 1/5 to get us to 7/5. So we're going to look at this on a number line. Remember, our number line always starts at 0, 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, and 10/5. And we know that 5/5 is the same thing as 1, and 10/5 is the same thing as 2. Now we have to say, how would we represent 7/5 on a number line? We know we got to have 7 jumps because we're going up 1/5 each time. So we're going to start at 0, 1, 2, 3, 4, 5, 6, 7. And there we are at 7/5. 7/5, 7 groups of 1/5. Now, you see that question at the bottom? It says 7/5 is in between which 2 whole numbers? Well, here's 7/5. We got our box. Here's 1, and here's 2. So 7/5 is what we would call an improper fraction. It's between 1 and 2. All right, so I want you to go back to your chart that you copied in your book. Look back at that, and we're going to make a linear model for 6/3. I want you to go back to that chart. We're going to make a linear model for 6/3. So I want you to go ahead and make your number line. Remember, our number line always starts at 0. We know we're using the unit fraction 1/3, so we're going to do 1/3, 2/3, 3/3, 4/3, 5/3, and 6/3. Okay, and we know that 3/3 is the same thing as 1, and 6/3 is the same thing as 2. All right, and we're going to 6/3. So we got 6 groups of 1/3. So we know we need to take 6 jumps. 1, 2, 3, 4, 5, 6. So 6/3 is the same thing as the whole number 2. It's the same thing as the whole number 2. Okay, so I want you to try one in your math journal. This is the one I want you to try for homework. I want you to try 6/4. I want you to try that. I want you to complete this whole chart for 6/4, and we will we will go over it tomorrow. 6/4. You're going to create all the sections.